गुड मॉर्निंग मैम।
गुड मॉर्निंग।
गुड मॉर्निंग मैम।
मैम एक चीज पूछनी थी आपसे।
बोलो।
मैम डाइवर्जेंस जो होता है वो आउटवर्ड फ्लक्स होता है,
हाँ,
उसमें इनवर्ड नहीं होता, तो मैम नेगेटिव डाइवर्जेंस कैसे हो सकता है?
इनवर्ड होता है अगर उसकी डायरेक्शन ऑपोजिट है तो वो नेगेटिव डाइवर्जेंस होता है।
एक बार थोड़ा समझा दीजिए मैम, समझ में नहीं आ रहा वैसे।
ठीक है बताती हूँ।
मैम गुड मॉर्निंग।
गुड मॉर्निंग।
गुड मॉर्निंग मैम।
गुड मॉर्निंग मैम।
गुड मॉर्निंग एवरीवन।
गुड मॉर्निंग मैम।
क्वेश्चन किसने पूछा था?
मैम मैंने।
हर्षित। ओके, सो
यस
यू आर
मैम।
कंफ्यूजिंग इट विद द डेफिनेशन ऑफ डाइवर्जेंस, राइट? डाइवर्जेंस में ये वर्ड लिखा हुआ था, इट इज आउटवर्ड फ्लक्स, है ना?
मैम पर यूनिट वॉल्यूम, हाँ मैम। यस
है
मैम।
ना? हाँ, तो डेफिनेशन में लिखा था दैट, मतलब वो एक पॉजिटिव डाइवर्जेंस या नेगेटिव डाइवर्जेंस नहीं था, डाइवर्जेंस की बेसिक डेफिनेशन। ठीक है, अगर
यस
पॉजिटिव
मैम।
डाइवर्जेंस होगा तो नेट आउटवर्ड फ्लक्स होगा। यू
यस
कैन
मैम।
थिंक इट लाइक जो डेफिनेशन थी डाइवर्जेंस की जो मैंने वो डिस्प्ले किया था, उसमें आउटवर्ड के साथ कंफ्यूज नहीं होना है। वो आउटवर्ड है पॉजिटिव डाइवर्जेंस के लिए, नेट आउटवर्ड फर्स्ट ऑफ ऑल।
यस
ओके,
मैम।
आई विल एक्सप्लेन इट विद एन एग्जांपल। सपोज कुछ लिक्विड फ्लो हो रहा है, राइट? फ्लो
यस
भी हो
मैम।
रहा है और अंदर भी आ रहा है, जो उसका इनलेट भी है और आउटलेट भी है। या फिर ऐसे सोच सकते हो कि रूम है, क्लासरूम है, दो डोर लगे हैं, उसमें एक डोर से बच्चे अंदर आ रहे हैं, दूसरे डोर से बच्चे बाहर जा रहे हैं। ठीक है, अगर एंट्री जो है बच्चों की, अंदर जो आ रहे हैं बच्चे, नंबर ऑफ स्टूडेंट्स कमिंग इन इज मोर देन नंबर ऑफ स्टूडेंट्स कमिंग आउट, नेट क्या होगा उसका रिजल्ट? इनवर्ड फ्लक्स होगा या आउटवर्ड फ्लक्स?
आउटवर्ड।
आउट। नहीं, अगर नंबर ऑफ स्टूडेंट्स एंटरिंग इज ग्रेटर देन नंबर ऑफ स्टूडेंट्स कमिंग गोइंग आउट फ्रॉम द रूम, उस
इनवर्ड।
केस में इनवर्ड फ्लक्स ज्यादा होगा। ठीक है,
यस
उस
मैम।
केस में क्या होगी? नेगेटिव डाइवर्जेंस होगी। यू कैन skip that word outward from the definition. कंफ्यूज नहीं होना, डेफिनेशन डाइवर्जेंस की यही है कि फ्लक्स जो है वो होना चाहिए, इट कैन बी इनवर्ड और इट कैन बी आउटवर्ड। बोलो शिवम।
ओके मैम।
यस मैम।
यस शिवम, यू हैव एनी क्वेश्चन?
नो मैम।
ओके, यू रेज्ड योर हैंड ना?
मैम अब से तो आप ही क्लास लेंगी ना?
हाँ हाँ, मैं ही क्लास लूंगी। वो एक दिन आई वाज नॉट अवेलेबल, सो ग्रेडियंट कर रहे थे हम, है ना, उससे कंटिन्यू करेंगे।
ओके मैम।
सो लेट्स वेट फॉर 1 more minute. सो क्या किया फ्राइडे?
मैम वेव ऑप्टिक्स।
कितना हुआ, क्या क्या
Wave
पोर्शन
optics.
कवर हुआ? आई विल स्टार्ट फ्रॉम like from the beginning only.
मैम
Interference I'll
कोहेरेंट
ask.
सोर्सेज,
In light
इनकोहेरेंट।
of interference.
Okay, but I'll start from the basics. Okay, जो मैम ने
ओके मैम।
करवाया
ओके मैम।
ठीक है, बट मैं स्टार्टिंग से पूछूंगी कि क्या क्या पता है, क्या क्या नहीं।
ओके मैम।
यस मैम।
You can mute yourselves for a minute. I'll wait for a minute for others to join. I think we should start the class.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So is my screen visible to you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so we were doing
Yes, ma'am.
gradient, है ना? So I was giving you an example of gradient. First of all, gradient हम scalar का लेते हैं. You can note it down, or you can note it after this slide also. So I was giving you the example of gradient. Example is the electric field. I'll write it here. So एक तो हम स्केलर फील्ड का लेते हैं, ये पॉइंट मैं डिस्कस करती हूँ बाद में, पहले मैं एग्जांपल दूंगी. सो इलेक्ट्रिक फील्ड इज एन एग्जांपल. क्या होता है इस इलेक्ट्रिक फील्ड की डेफिनेशन किसने बताई थी उस दिन? कैसे लिखते हैं एक्सप्रेशन फॉर इलेक्ट्रिक फील्ड इन टर्म्स ऑफ पोटेंशियल?
माइनस ग्रेडियंट ऑफ पोटेंशियल.
बट बोला क्या था? dv by dr.
माइनस dv by dr. यस
है
मैम.
ना? और पोटेंशियल को डिफाइन कैसे करते हो? इंटीग्रल ऑफ E डॉट dl ऐसे करके, है ना? नेगेटिव ऐसे करके करते हैं. मैं ये जनरलाइज लिख रही हूँ, इसको स्पेसिफिक नहीं है इतना ये एक्सप्रेशन. एनीवेज, इलेक्ट्रिक फील्ड क्या है? माइनस dv by dr. सो चेंज इन पोटेंशियल, इसको हम लिख सकते हैं माइनस डेल v, दैट इज ग्रेडियंट ऑफ पोटेंशियल. डेल ऑपरेटर क्या होता है? आई कैप कार्टेशियन में आई कैप पार्शियल डेरिवेटिव विद रिस्पेक्ट टू x प्लस आई जे कैप. ये इधर भी लगा सकते हो, राइट? आई कैप जो है मैंने लेफ्ट पे लगाया है, इधर भी
Okay,
लगा
ma'am.
सकते हो राइट पे. डेल बाय डेल वाई प्लस के कैप डेल बाय डेल जेड. अच्छा, ये डेल ऑपरेटर है, मतलब ये किसी चीज पर ऑपरेट करेगा, राइट? कैसे ऑपरेट करेगा? जो भी फंक्शन इधर है, ये क्या है? पोटेंशियल. पोटेंशियल जो है स्केलर फंक्शन होता है. स्केलर मतलब इसकी डायरेक्शन डिफाइन नहीं करते, हम सिर्फ मैग्नीट्यूड डिफाइन करते हैं. अगर हम इसको फंक्शन फॉर्म में डिफाइन करें, हम इसको एक्स वाई जेड का फंक्शन भी बोल सकते हैं, एक्स वाई भी बोल सकते हैं, ठीक है? कोई भी इसकी फॉर्म हो सकती है. लेट्स से 2x प्लस 3xy, लेट्स से ये पोटेंशियल की फॉर्म है. स्केलर फंक्शन क्यों बोल रहे हैं पोटेंशियल को? कोई बताएगा? स्केलर है वाई क्योंकि मैग्नीट्यूड है, सिर्फ डायरेक्शन डिफाइन नहीं करते पोटेंशियल में. स्केलर फंक्शन क्यों बोल रहे हैं?
क्योंकि डायरेक्शन नहीं है मैम.
स्केलर हो गया ना. फंक्शन क्यों बोल रहे हैं? क्योंकि फंक्शन है एक्स वाई जेड का, राइट? सो पोटेंशियल अगर ऐसे डिफाइन कर रहे हैं हम, वी एक्स वाई जेड इज इक्वल टू 2x प्लस 3xy, एक एग्जांपल दे रही हूँ मैं सिर्फ, तो इस केस में पोटेंशियल एक स्केलर फंक्शन है, ठीक है? तो ये जो v है, हम इसको ऐसे भी लिख सकते हैं सिर्फ v, और हम इसको इस प्रॉपर वे में भी लिख सकते हैं कि जो v है वो एक्स वाई जेड का फंक्शन है. इन फंक्शनल फॉर्म भी लिख सकते हैं, ठीक है? कंप्लीट अगर लिखना है तो वी एक्स वाई जेड लिख सकते हो, अगर शॉर्ट फॉर्म में लिखना है तो सिर्फ v लिख लो. तो मैं बात ये कि जो ऑपरेटर है डेल ऑपरेटर, ये v पे ऑपरेट होगा. कैसे ऑपरेट होगा? आई कैप, पहले हम v का पार्शियल डेरिवेटिव करेंगे विद रिस्पेक्ट टू, ठीक है, प्लस जे कैप, फिर पार्शियल डेरिवेटिव करेंगे विद रिस्पेक्ट टू y,
वही.
फिर के कैप पार्शियल डेरिवेटिव विद रिस्पेक्ट टू z. किसी ऑपरेटर को ऑपरेट करवा रहे हो किसी फंक्शन पे, तो ऐसे होगा. पहले उसका ये डिफरेंशिएट करेंगे x के विद रिस्पेक्ट टू, फिर y और फिर z. तो ग्रेडियंट ऑफ v को हम इस तरीके से लिख सकते हैं. तो इलेक्ट्रिक फील्ड ये हो गया, ठीक है? ये इलेक्ट्रिक फील्ड वेक्टर है. इसके ये 3 कंपोनेंट्स हैं. इसका क्या मतलब हुआ? कि जो इलेक्ट्रिक फील्ड का x कंपोनेंट है वो किसके इक्वल होगा? बताओ.
सर मैम माइनस आई कैप पार्शियल डेरिवेटिव ऑफ x.
आई कैप तो नहीं आएगा. हाँ, अगर लिखना है
I cap-
डायरेक्शन, यस. अगर सिर्फ मैग्नीट्यूड लिखना है तो Ex इज इक्वल टू माइनस डेल वी बाई डेल एक्स. सिमिलरली Ey क्या हो जाएगा? माइनस डेल वी बाई डेल वाई. और Ez क्या हो जाएगा? इसे एक डेफिनेशन मैंने उस लास्ट टाइम भी बताई थी जब ये कर रहे थे ग्रेडियंट, कि ग्रेडियंट क्या होता है, rate of change, component of gradient of a function in a particular direction is the rate of change of function in that direction. तो वही है ये इलेक्ट्रिक फील्ड क्या है, ग्रेडियंट ऑफ पोटेंशियल। बेसिकली इलेक्ट्रिक फील्ड ग्रेडियंट है, किसका है, पोटेंशियल का है, बट है ग्रेडियंट। सो इलेक्ट्रिक फील्ड का जो एक्स कंपोनेंट है वो रेट ऑफ चेंज इन एक्स डायरेक्शन है, वाई कंपोनेंट जो है वो रेट ऑफ चेंज इन वाई डायरेक्शन है, z कंपोनेंट जो है वो रेट ऑफ चेंज इन z डायरेक्शन। किसका चेंज है, पोटेंशियल का है। ये क्लियर है। ग्रेडियंट की डेफिनेशन ऐसी ही करी थी हमने, ये देखो, कंपोनेंट ऑफ ग्रेडियंट ऑफ अ फंक्शन इन एनी डायरेक्शन is defined as rate of change of function in that direction. So electric field के केस में ये किसका rate of change है, potential। क्लियर है ये?
यस मैम।
किसी को कोई डाउट हो तो पूछ ले अभी। और एक और चीज, अभी ये जो सेकंड पॉइंट है, इट पॉइंट्स अलोंग द डायरेक्शन ऑफ मैक्सिमम चेंज। ये मैं समझाती हूँ एक एग्जांपल के साथ। सपोज ये एक रूम है, पोटेंशियल की जगह पे हम अभी स्केलर फंक्शन ले लेते हैं टेम्परेचर। टेम्परेचर को मैं डिफाइन कर सकती हूँ एक्स वाई जेड की फॉर्म में। मान लो ये टेम्परेचर है किसी रूम का, ये स्केलर क्वांटिटी होती है टेम्परेचर, एंड ऑल्सो आई एम डिफाइनिंग इट इन द फंक्शनल फॉर्म, सो ये स्केलर फंक्शन है। इसकी भी मैं कोई भी फॉर्म अज्यूम कर सकती हूँ। मान लो लेट्स से 3y² + 6z, दिस इज द फंक्शनल फॉर्म ऑफ टेम्परेचर ऑफ अ रूम। तो इस पॉइंट पे मान लो इसके कोऑर्डिनेट्स हैं 1 2 3। टेम्परेचर क्या होगा, T is equal to y is equal to 2, so 2 square 4 into 3 12 plus 6 into 3 13, so ये आ गया 30। So at point 1 2 3 टेम्परेचर की वैल्यू है 30। जैसे जैसे हम रूम के कोऑर्डिनेट्स चेंज करेंगे the temperature will change, right? So different points पे temperature will have different value. मान लो I want to find the gradient of temperature at this point. Okay, so in the vicinity of this point there are number of points, let's say this, in different directions, point A, point B, here point C in this direction. Temperature will have different value on these points. Let's say at A, temperature of the room has value 12. At point C, temperature of room has value 32. And at point B, temperature of room has value 25. So when you are going from this point P towards A, B or C, in which direction the temperature of room is changing maximum? When you go from point P to point B, what is the change in temperature? When you go from this point P to point B, what is the change in temperature? Yes, 5. So point P towards point B, the temperature change is 5. When you go from point P towards point A, what is the change in temperature?
-5.
No, towards A. It's
-5.
12. It's 12 here. Yeah, -5. I'm writing only the magnitude, the change. Either it is
I'm
18 or
18.
18. And when you go from point P towards point C, what is the change?
It increases by
28.
So where, in which direction there is maximum change in temperature?
A point.
A point. So the gradient of temperature, if you find at this point, at point P, it will direct along this point. That is, it points along the direction of maximum change. This is the definition of gradient. That if you find the gradient of temperature, this function which I am defining here, if you find the gradient and put the values 1 2 3 in gradient, you will get the direction of gradient will point along the direction of maximum change. I'll repeat this. Okay. The
Will it
direction
have
of,
any negative or positive?
yes. If you find the electric
Will it
field,
have any negative or positive value to tell that the temperature is decreasing or increasing?
yes, I'm saying, yes, listen to me. If you find the electric field, you can replace now the temperature with electric field. You're finding electric field, that is, you're finding the change in potential over here, right? So electric field, it has magnitude also, it has direction also. For a negative charge, you will get the electric field pointing. If you have a negative charge, what will be the direction of electric field?
Inwards.
Inwards.
Towards negative charge.
And for positive, it is away from the charge.
Away from the charge.
One thing is direction, that you can get the direction of electric field. You will also find the magnitude of electric field. It will decrease as you move away from the charge, right?
Yes, ma'am.
Yes, ma'am.
Yeah, electric field near in the vicinity of charge is maximum. As you go away from the field, it is decreasing. So the direction of gradient is the direction of maximum change. Either it is increasing or decreasing. It will be conveyed to you from the sign of the gradient. The sign of gradient will tell you whether the field is decreasing in the direction of maximum change or is it increasing in the direction of change. Here I am writing 25, 30 and 32 randomly. I have not put the value of the function in this functional form. I've just, to give you an example, to give you an idea, I just wrote randomly 25, 30 and 32. I can give you a proper example where these values you can find out by putting the coordinates in this functional. Okay.
Okay, ma'am.
The idea is that the direction of gradient points along the direction of maximum change of the function.
Yes, ma'am.
So you can solve this numerical equal to x plus 3y square.
One plus 6y.
Okay. PPT yourself. I discuss the numerical. Mute yourself. Is it solved?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, tell me the answer now.
1 plus 6y.
1 plus
1
6
plus
pi.
6y.
So is it a scalar or vector?
Vector.
So where are the unit vectors? One in 1 plus 6y. This is the scalar.
I plus 6yj.
Yes. I cap plus 6y j cap. So gradient of f is equal to I cap del by del x del by del y plus k cap del by del z. Operated on this f function, which is x plus 3y square. किस किस का गलत आया था आंसर? If you have not put the direction, then also it is not the correct answer, right? So you can write the proper steps so you can avoid the mistake.
Okay, ma'am.
Then you will do a lot of practice, then you can solve it in a minute. Otherwise, write all the steps. So gradient of a scalar is a vector or scalar quantity?
Vector.
It's a vector quantity. You can remember this from electric field example also. Electric field is an example of gradient and electric field is a vector quantity. So this is I cap plus 6y j cap. Those who want to write, I'll give you 30 or 40 seconds, write this down. Just write it quickly.
Done, ma'am.
Okay. So in this numerical, you first find the gradient of this function. Okay. When you get the value of the function, then you put this point and find the value at this point. Find its mean, find the value of gradient at point 2, 3. Find the value of gradient at point 2, 3. Solve this numerical.
Nine I cap plus 28
Done.
J cap.
Yes, correct.
9 plus
9
28 J.
IK plus 20 G.
Correct, correct.
Yes,
So
ma'am.
we'll solve it here also. Del F is equal to del operator. This del operator is very important thing. You will come across del operator in Schrodinger equation also, right? In fact, in quantum mechanics, this del operator is quite an important quantity. Important thing you can say, not quantity. Del operator operating on this f function, which is Vx square plus y. So when you solve this, you first do partial derivative of this f function plus j cap. Partial derivative with respect to z is 0, as this function f is not a function of z. So when you do derivative with respect to x, you get 6x minus 3 plus j cap 3y square plus 1. So this is the value of gradient del f is equal to this thing. First you find the gradient of this function. Then you have to find the value of point this. So del f at point p 2, 3 is equal to, you just put the values of x and y. 6 into 2 minus 3 plus j cap 3 into 3 square 9 plus 1. Solving this, you will get 9 I cap plus 28 j cap. Those who want to write this down, please write. Can you find the direction of gradient from this numerical also? You have got the gradient. Can you find the direction also?
Yes, ma'am.
How?
मैम इसका यूनिट वेक्टर निकाल लेंगे.
Yes. So you can find the direction of gradient at this point P. You can divide the magnitude of this vector with itself and you will get the direction of gradient. So basically, if n cap is the unit vector in the direction of gradient, then this is equal to 9 I cap plus 28 j cap divided by its magnitude, which is 9 square plus 28 square under root.
865.
Yeah, no need to solve this. I just wanted to give you an idea. Okay, I think it is done. So solve this one, it's quite similar. Just the answer there today.
Phi pi plus 4j plus 3k.
Correct.
Phi y plus 4j plus 3k.
Correct. So the gradient is so gradient is basically derivative, right? It has direction also, and it is also called directional derivative.
Yes, ma'am.
It is basically a differentiating, right? And it has direction also. So it is called directional derivative. So sometimes in numericals, they don't ask to find the gradient. They ask to find the directional derivative at this point, like here. It's another term used to depict the gradient. So So when you solve this, you will get that direct gradient is y plus z I cap plus x plus z j cap plus x plus y k cap.
K cap.
And when you put the value of this point, this is gradient. And if you want to find the value of the set point P 1, 2, 3, this is equal to 5 I cap plus 4 cap plus 3 k cap. And this is mostly done. We'll continue to interference. I'll start from the basics, like what you people know about interference. So I was also telling you to like we will discuss at one day about the number of units you will have in your first semester physics. So the course is engineering physics, right? So there are 5 units in total. First one is relativistic mechanics. Relativistic mechanics. Second is quantum mechanics.
Yes, ma'am.
Third one is wave optics. Fourth is semiconductor physics and information storage. Information storage. And fifth one is fiber optics and laser. So basically now for some May you will have your 3 sessionals will be there. 3 sessionals होंगे, ठीक है? Class test होंगे. उनके marks will be combined with your attendance or assessment thing. So you will have internal, which will be 50 marks. It will comprise of these 3 sessionals, class test, your attendance, assessment, all will be averaged out. Okay. Attendance.
Okay, ma'am.
Yeah. So this will be accounted for in internal. Theory internal, you say 50 marks. And then theory external, it carries 100 marks. Your NSAM examination, so total will be 150. So engineering physics theory, the total is 150 marks. 50 marks is the internal and 100 marks is the external paper, which will be at the end of the semester. And in your lab, you will be having 25 marks paper for internal. There will be an internal practical exam and 25 will be the marks. And then there will be external practical. Both will be at the end of the semester. External practical, it will also be of 25 marks. So your lab is also carrying 50 marks separately. Okay. So these are separate from each other in lab and theory exams. So lab को भी attentively करना, जब आओगे तो lab को भी ध्यान से करना, इसमें भी बैक अलग से लग जाती है, नहीं तो अगर properly experiments perform नहीं करोगे.
ओके मैम
मैम आप एक बार और एक्सप्लेन कर देंगी?
ओके सो जो थ्योरी है इसमें लिखती हूँ मैं, ठीक है। जो थ्योरी है फिजिक्स की, इंजीनियरिंग फिजिक्स, ठीक है, इसमें होगा एक इंटरनल। इंटरनल में क्या क्या इंक्लूड होगा, 3 सेशनल्स होंगे, ठीक है। इन योर सेमेस्टर थ्रू आउट देयर विल बी 3 सेशनल एग्जाम्स, 1 after a month, okay. So 3 sessionals will be there, 30 marks, carrying 30 marks each. Then there will be class test every week or alternate week that will be scheduled, okay, and will be intimately to you. There will be class tests, and then there is attendance, marks for attendance also, or you can say assessment, attendance or assessment. So these things are covered in internal, which carries 50 marks. And then there is NSEM examination, also called external theory exam. At the end of exam semester, there will be 100 marks paper. Okay, so the total 50 and 100 is 150. So your theory paper carries 150 marks. So end semester exam is of 100 marks, and your 3 sessionals after like in the 3 months there will be 3 sessionals, and then there are class tests accordingly scheduled. Then there is attendance. All these things carry 50 marks. These will be averaged out. So 150 marks theory paper, and then there is lab. Lab paper is separate. So at the end of semester, there is, first we take internal exam. It carries 25 marks. Then there is external exam, where external from some university or college will come to take the exam. External exam also carries 25 marks. So the total lab comprises of 50 marks. Lab exam, practical exam. Both will have different boards, theory paper and practical paper. Clear now?
सब्जेक्ट से फर्स्ट ईयर में
Yes, ma'am.
Sorry?
फिजिक्स सब्जेक्ट सिर्फ फर्स्ट ईयर में है
First semester. In one semester, you will study physics.
एंड सेकंड
There is electrical engineering. Electrical.
मैम
Okay.
फर्स्ट सेमेस्टर अराउंड कब होगा?
Offline classes, it will be on from 3rd of October. Tentative date is 3rd October. But the confirmed will be, you will get a message from the college. Okay, email or text message you will get. But the tentative date is 3rd of October. Okay.
फर्स्ट सेशन कब होगा? एक्चुअली मैं गलत बोल दिया।
Sessional you are asking? Sessional paper exam?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
the general criteria is after your classes are on a month or so. It is not scheduled yet, na? So it all generally takes a month. After a month, there is a session.
Okay, ma'am.
So it will be scheduled
एक महीने
accordingly.
बाद सेशनल एग्जाम होगा सबका, मतलब जब से क्लास चालू हुई है उससे 1 महीने बीत जाएंगे तो सेशनल एग्जाम होगा सबका। और
tentatively I am
3
saying.
होंगे एक सेमेस्टर में 3
Yes. Tentatively I am saying 1 month. It can be plus
सेशनल
or
एग्जाम
minus.
लिखिए, पता नहीं
Okay.
क्या मीट तो नहीं बोली ऐसा कुछ।
क्या? Aryan, what are you saying?
माइक ऑन कर रखा मैम उसने, किसी और को बता रहा होगा।
So tell him that his mic is on. Okay, so we'll move to interference. चलो बताओ फिर इंटरफेरेंस में क्या क्या पता है?
आप डायरेक्शनल डेरिवेटिव बता रही थी अभी क्वेश्चन में।
Directional derivative, that's I just introduced the term to you. That's it.
Okay, ma'am.
That we are differentiating right in this, and there is direction associated, so it is also called directional derivative. I was just saying that.
Okay, ma'am.
Gradient is अभी थोड़ा सा और है, but that is not important. Like for you right now, that I've just introduced the term gradient and some mathematical expression. How do you find it and all. इतना ज़्यादा syllabus में है नहीं gradient. Okay? किसी किसी चीज में काम आएगा. That's why I've introduced this. Otherwise, there is no separate topic in your syllabus for the gradient. So I've like confined myself also by telling the gradient. Okay, so now tell me electromagnetic waves. Any example of electromagnetic waves? EM waves. Any example?
Light.
Ma'am,
Light. Yeah, light. Sound.
Light.
Who said sound? Is sound an electromagnetic wave?
No, ma'am.
Yes, issue. Sound is not an electromagnetic wave. Yeah, so light is an example of electromagnetic wave. Another examples?
Ma'am, X-ray, gamma ray.
Yes, X-rays.
Radio waves,
microwaves.
microwaves.
Yes.
Microwave.
Okay, so
Infrared.
gamma rays, infrared rays.
Ultraviolet.
Yeah, so UV rays, you know, that is sunlight. UV rays are a component of sunlight, right? Infrared rays,
Yes,
you
ma'am.
also know that it is also a component of sunlight. The thermal part is mostly composed of infrared waves. X-rays, you know that there is X-rays are used for in medical treatment and all. So where does gamma rays use? Where you heard about gamma rays?
Radiation.
Yes, radiation. In context of what? Like where have you heard about gamma rays?
हम
Ma'am,
ट्रीटमेंट के लिए
कैंसर ये पेशेंट को ट्रीटमेंट के लिए होता है.
Yes. Okay, fine. So yeah, light is an example of electromagnetic wave, but light also carries is also a form of particle, right? Is light and wave or a particle?
Ma'am, it has dual
characteristics.
Ma'am, we
Yes,
get
ma'am,
dual
dual
nature.
nature. It has
Okay,
dual
it has
nature.
okay.
Particle and wave.
It has dual nature. तो कैसे पता चलेगा कि कहाँ पे कौन सा नेचर लाइट एग्जिबिट कर रही है?
ये ऑब्जर्वेशन पे डिपेंड करता है.
किस ऑब्जर्वेशन पे क्या डिपेंड करता है?
जैसे कि अगर लाइट की जो वेवलेंथ है, अगर किसी बहुत के आकार से बड़ी वस्तु होगी उसके सामने तो वो पार्टिकल नेचर शो करेगा, और जब उसकी वेवलेंथ के बहुत पास होगी तो वो वेव नेचर शो करेगा.
Is it? When light is propagating, sunlight is coming from the space towards us, right? It's exhibiting wave nature or particle nature?
Both. Wave nature.
So basically, when light is propagating, so traveling phenomena, light exhibits wave nature. But when it is interacting with some matter or interacting with something, it exhibits particle nature. So so interference.
मैम, कोहेरेंट सोर्स होना चाहिए और
एक second. No.
difference zero होना
One second. So I'm saying light exhibit both wave and particle nature. When does it exhibit wave nature?
when it's propagating.
When it is
When
propagating,
traveling.
like the traveling phenomena. Okay? Traveling phenomena. And when does it exhibit particle nature? When it is
When during
interacting with
interaction.
something.
I'm interacting with some matter or
Interacting with
something.
matter or something. So an example of phenomena for both?
Ma'am, for wave, it's interference.
So what happens in interference? Basically, it is traveling and it encounters a slit. It changes its path and then interference phenomena happens. An example of phenomena where particle nature is
Photoelectric
exhibited.
effect.
Photoelectric effect.
So what is photoelectric effect?
Ma'am, emission of
When light interacts with a metal plate,
फोटोन
electrons
जब
is
मेटल पे गिरते हैं इमिशन
One
ऑफ
by one,
इलेक्ट्रॉन.
one by one. Ansh, what is photoelectric effect?
When sunlight falls on a metal plate, electrons are ejected from it, and kinetic energy is released.
So is it necessary that
I mean,
it encounters? So is it necessary that it encounters a metallic surface?
Yes, sir, it should contain electrons. No?
Why only metallic surface?
Because metal
Ma'am,
contains
because
are
metals have free
in the
electrons.
Okay, then
Yes, ma'am.
then
It takes
metal
less
has free
energy to
electrons.
produce electrons.
Produce electron or eject electrons?
Eject electrons.
Eject.
Yeah, its work function is less. In which energy range does lie the work function of a metal? What is the unit for energy? Work function, you write it like 5. For sodium and etc. metals, you must have like solve this in numerical, that work function is given in something. So in which energy range does the work function of a typical metal lies? Yes, electron volt.
electron volt.
Yeah. So in photoelectric effect, electrons are ejected from the metallic surface when light of sufficient frequency falls on the surface. Why not electrons with lesser energy, light of lesser frequency be able to eject the electrons? There is some threshold frequency, right?
Yes, ma'am. It's the minimum.
Yes, ma'am.
Yes, ma'am.
So there is some threshold frequency below which light is not able to eject the electrons. Why so?
Ma'am, it requires some kinetic energy.
Why can't it happen? Why can't it happen that light is continuously falling on an object and object is storing energy or collecting energy, and then electrons are able to eject from the surface? Why can't it happen? Why only a threshold?
Ma'am, it's in a discrete quantity, not a continuous form.
Yes. Yes. That is why we say that light exhibits particle nature. Here, this continuity,
Yes,
if we consider the wave nature of light, then this cannot be explained, because wave is some form of continuous emission or absorption of energy. That is where the particle nature of light comes from. Yeah.
ऑनलाइन क्लास
Sorry. Tell him that his mic is on.
अरे कॉल कर रहा हूँ मैं, बस 10 मिनट में खत्म होने वाला है.
Ankit? Okay. Okay. So this is where from where the particle nature is coming. That if wave has light has wave nature in photoelectric effect, then there is not any threshold frequency. There is no need that the frequency of wave should be larger than some threshold frequency. Anyways, okay, so light has both wave and particle nature. It depends upon the phenomena that which nature will be dominating or which nature light will exhibit. Okay, so what are coherent sources?
Which are the same phase.
And with a constant phase difference.
Same frequency.
Same frequency and a constant phase difference.
What do you mean by constant phase difference?
Path difference में 0 हो जाएगा.
No, zero is not necessary.
Ma'am, path difference.
No.
Path difference should be same.
If it has some path difference, then there is some phase difference also.
Yes, ma'am.
Yeah.
Yes.
Okay. So this is the wave, simplest wave, right? Normally light is not a series of such waves. Actually, we only consider this as the ideal case, right? So this is a sinusoidal wave. What is the equation of this sinusoidal wave?
Y is equal to A sin omega t.
Sinusoidal wave, right? Y is equal to A
Sin
omega t.
Yes.
Correct. What is A?
Amplitude.
It is the maximum displacement, right? This is A. What is Y?
Thanks.
Position
Position.
Yes,
Displacement.
displacement of the current
Movement
displacement
of
of the wave, right? At a particular time. Okay, so what
Yes,
is
ma'am. Instant.
omega? What is omega?
Angular.
angle.
Angular frequency. In terms of linear frequency, what is the expression?
Ma'am.
2 pi
2 pi f. Okay, so what is frequency?
2 pi by 2.
Per of oscillations per unit.
1 over t. Right.
Yes, ma'am. 2
So
pi by t.
what is t?
Time period.
Okay,
Time period.
How do you define the time period of wave?
Ma'am, time to complete one oscillation.
How do you know that one oscillation is completed?
Mean position.
How do you know from this wave that one time period is completed?
And the starting angle and the last ending angle is same. Like
Yes.
it starts from 0 and reaches from 0.
Yes. Basically, one wavelength is covered. Right? You can start from here or you can start from there also. Then when one wavelength will be completed? Here. So this is the time period. If this axis is time you're taking. This is the time period of wave. Okay, fine. So tell me, one wave is this. Another wave is this. What is the phase difference between these two? Okay, first tell me what is the phase. If instead of sin omega t, we write it like sin omega t plus phi. So there is some initial phase, right, in the wave. What is phase difference?
Pi by 2.
Pi by
No,
4, ma'am.
in general, what is phase difference when you studying waves? What is the phase difference between two waves in general? It tells you the starting point, right? Or the instantaneous displacement. At this point, what is the phase of the wave? This wave 1 and this is wave 2. So at this point, highlighted with the blue color, what is the phase of the wave?
90. No.
Tell me here.
Pi by 2.
Tell me here first. What is the phase of the wave?
Pi by 2 pi.
Here.
Pi by
Here.
2 pi.
I'm asking first here.
Ma'am, 0.
0. Okay. What about here?
90
Pi by 2.
Here it is pi. Here
Pi.
it is 3 pi by 2. Here 2 pi.
2 pi.
So what about this one?
5 by 2 pi.
5 pi by 2. Yes, 5 pi by 2. Now the phase is clear. So tell me the phase difference between waves 1 and 2.
Pi by 2. Minus pi
Yes,
by 2.
the phase. Okay, yes, the phase difference is pi by 2. Now what is path difference? Now what is path difference?
प्लास्टिक जो है ये वाली ये उससे भी जुड़ी है इस बॉडी से, इससे भी जुड़ी है दीवार से भी.
So if this continues like this, now you people don't mute yourselves and you're taking classes and you're doing these things, I'll mute you all from tomorrow onwards. So when you're discussing on the forum now, you tell each other that mute yourselves while having these kind of discussions which are not needed for the class, for others to listen, okay? So tell your classmates this thing. Otherwise, I have to mute you all from tomorrow onwards.
Okay, ma'am.
So if you want one-to-one interaction in the class, tell others in a proper manner. Okay, so now tell me what is path difference? How do you define path difference?
Difference between two waves.
Path difference is
when
defined
we are
in terms of wavelength. Path difference is defined in terms of wavelength. So if you are saying the phase difference between these two waves, 1 and 2 is pi by 2, then path difference is
Lambda by 4.
lambda by 4. Yes.
Yes.
How do you see this from this figure that path difference is lambda by 4? You can see it from here now. The first wave starts from here and the second wave is covering this extra path. This extra path is quarter of a wavelength.
Yes, ma'am.
This is 1 by
Yes,
4th
ma'am.
of a wavelength, complete wavelength. Right?
Yeah,
Yes.
yeah.
So the phase
Yeah.
difference is
Yes,
pi
ma'am.
by 2 and the path difference is lambda by 4. So this is the general
Lambda.
formula for the relation between phase and path difference. Phase difference is equal to 2 pi by lambda into path difference. You
Okay,
note
ma'am.
down this formula. Note this formula down. We'll continue
ma'am.
this discussion. We'll continue this discussion from tomorrow in tomorrow's class.
Okay, ma'am.
I'll take your attendance now. You write this formula. Yes, Aditya? Is it done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, fine. 1 second.
Ma'am,
Don't leave
excuse
the
me, ma'am.
class. Yes.
मैम ऑफलाइन क्लासेस 3 तारीख से चलेंगी.
Tentative date is yes, 3rd of October.
ओके मैम. थैंक यू मैम.
मैम इतना लेट क्यों हो रहे हैं?
वेट मैम.
इंडक्शन प्रोग्राम है, वो खत्म
Yes.
होगा तो क्लासेस स्टार्ट होंगी. ठीक है, ऑनलाइन.
ओके मैम. ओके मैम.
मैम अटेंडेंस हो गया?
1 second. Yes.
Thank you, ma'am.
Thank you all.
Thank you, ma'am.